Floating in the middle of the Pacific Ocean are three marine garbage patches made up of tiny pieces of plastic and man-made debris. Scientists are focused on cleaning up these concentrations of litter. Here to discuss the effort and why it's important is Amy Uhrin, Chief Scientist for the Marine Debris Program at the National Oceanic and Atmospheric Administration, known as NOAA. So the Pacific gyre, I've seen the descriptions that it's the size of Texas. I mean, we're not talking about one actual physical structure in the middle of the ocean. It's millions of small parts.
So let's first talk about what the garbage patch is not. So it's not a floating island of trash. You know, the phrase conjures up this image of maybe a large vortex of human-derived waste, and that's not what's out there. So the gyre is mostly made up of these smaller plastic fragments, fragments of larger pieces of plastic items that have broken down over time. And those pieces are actually distributed throughout the water column. They're not necessarily floating on the surface, and they're very small, similar to the sample that I've brought in here. They can be very, very, very tiny. And the reason that they're concentrating in this area is actually because this is an area inside an oceanic gyre. Think of it as a massive, slow-moving whirlpool, if you will. The middle of the water body is relatively calm and stationary, but these currents are moving around and around that central water mass. And what happens when you have a whirlpool? Things start to gravitate towards the center. So these gyres are pulling in floating items across the ocean into the center. And there's not just one gyre. There are actually 5 major gyres across the globe, but the North Pacific gyre is the most popular, and the garbage patches that are associated with that gyre tend to get a lot of attention.
When you said deeper down in the water column, how deep does this trash go?
Folks have actually found microplastic and plastic pieces in benthic sediments. So at the bottom of the seafloor, in sand, in muddy surfaces, they're distributed throughout the water column. And so the concentrations and densities of shoreline debris are easier to quantify and measure because you can go out to a beach and collect items and get an idea of what's out there. But currently, researchers they're not having a difficult time, but it's harder to quantify these tiny pieces when they're floating throughout the water column or they're in the sediment, because you've got to send gear down there that can capture the sediment and bring the samples back up. So it's not an easy task to get a handle on how much.
And what's the impact of this on marine life?
We know right now that over 600 marine species have been affected by or have ingested marine debris of some kind. And so if we're talking about plastic particles, they almost see these as food items, right? And so they unwittingly take them into their system. Sometimes the plastic pieces have very rugged or serrated or sharp edges that can puncture or perforate the digestive system, which can cause obvious problems. Also, if they eat a lot of plastic and they have a lot of plastic in their gut, it gives them the feeling of fullness, and so they don't eat anymore. And obviously, plastic doesn't have any nutritional value, so eventual starvation could occur. But in addition to just those physical, direct physical impacts, plastics have additives. They have chemical additives in them to make them pliable, to make them last a long time. And those chemicals can actually leach out of the plastics when they're in the environment. They can leach into the water column, they can leach out on land, they can leach out in the digestive system of an animal. And so that's also a problem. Plastics, when they're in the environment, they can also adhere other chemicals to their surfaces. So when an animal takes that in, they're now exposed to this chemical cocktail, if you will. And what's really not well known right now is how those chemicals can then cross barriers into tissues, into organs, and things of that nature. But plastic ingestion has been documented in the smallest animals, zooplankton, on up through whales, fish, seabirds, bivalves, oysters, mussels.
When we think of a remote tropical beach somewhere or someplace in the ocean, we think of these beautiful white sand, et cetera, but there's also islands that have this stuff washing up on it.
Since the inception of our program in 2006, we have actually partnered with another NOAA program, another NOAA line office, actually, the National Marine Fisheries Service. And they conduct research cruises out to the Northwest Hawaiian Islands, very remote location, about 2,500 miles from the United States. That's where Midway Atoll is. So there's really no human inhabitation there, except you've got a few very small military installations. But on those cruises, for example, just last year, they removed 57 tons of derelict fishing gear from these islands where nobody is living. Also, you can walk along the shorelines there and just see piles of material that look like this, only on a much larger scale. So it all has to do with location, where the islands are situated. They're very close to that gyre that I was talking about earlier. And so even though trash is not being generated on the islands and washing into the water, it's coming from elsewhere.
How do you clean up this mess?
Our program did some very simple back of the envelope calculations, and we determined that if you had, and this is just barring, this is assuming that the method worked to a T and you had an endless budget, et cetera. And we determined that if you had 100 ships, they were each towing a net that was 200 meters across. They towed for 10 hours a day, going about 10 to 12 miles an hour. They could cover less than 2% of the North Pacific gyre in a year. And so at those same rates, you could cover the entire gyre in about 50 years. But the problem is you haven't turned off the faucet, right? So plastics are still entering the environment. They're still getting out to the gyre. So think of it as if you were home, all of a sudden your sink or your bathtub were overflowing and you're running in there with a mop and a bucket and some towels, and you're trying frantically to clean it up, but the faucet's still running, so the water's still overflowing, and it's a very difficult and daunting task.
So how are these, is this through our storm drain systems that go out into the ocean? I mean, how's all this plastic getting in there?
So a paper came out last year in Science from a researcher. The lead author was a researcher from the University of Georgia. She's a waste management specialist. And so they looked at waste management practices in 192 countries across the world, coastal countries. And what they found out was that it's actually coming into the oceans through mismanagement, waste mismanagement. And so what they found was that the top 20 countries actually contribute to about 83% of the plastics washing into the ocean. And they estimated, on average, about 8.7 million metric tons of mismanaged plastic get washed into the ocean annually. So it's a global problem. At the same time, solutions can be local. So just improving waste management in certain parts of the globe can effectively reduce what's being input into the marine environment.
What's that local solution you're talking about?
It's going to take a concerted effort between governments across nations to work toward maybe improving those types of infrastructures in these countries, and also locally. So everybody thinks, well, I'm just one person, what can I do? But if you've passed that message along, and that's often a focus within our program, the NOAA Marine Debris Program, so we put a heavy emphasis on prevention through education and outreach. And every year we actually hold a grant competition to award projects monies to try to teach about the issues of marine debris. So how to recycle properly, understanding that there are a lot of single-use disposable plastics out there, so maybe there are other alternatives you can use. We like to focus on the 3 R's: reduce, reuse, recycle, and things of that nature. So prevention is really key in educating the public about what they can do, because it does make a difference. It all adds up.
Amy Uhrin from NOAA, thanks so much.
Thank you.